Hi, I'm Jeff Briton from Laser Components Canada. Today I'm going to be talking to you about challenges in operating pulse laser diodes for LIDAR applications in the automotive and sensor marketplace. So with applications for pulse laser diodes or PLDs expanding into high precision distance measurement systems, including automotive safety scanners, the old challenges of energizing the devices become ever more significant. In order to achieve the distance resolution demanded by modern time-of-flight ranging systems, shorter and shorter pulses need to be generated. The wavelength of choice for the majority of safety scanning applications is 905 nanometers. The primary advantages of this wavelength are cost and the efficiency provided by the triple junction epitaxial designs. No matter what wavelength of PLD is chosen, the switching of the drive current at very high speeds remains critical to achieving the range and distance resolution. Because PLDs are current activated, the inductance in the drive circuitry is a limiting factor to generating fast rise times and short pulse widths. Discrete circuitry may not provide connections short enough to reduce inductance in the drive current path, so a trend towards hybridization of the PLD and driver often offer the best solution. To do so requires combining the critical components, namely PLD, charge capacitor, and switching element, to be assembled in very close proximity to one another. Typically, all of the components are packaged and connected inside a 1 to 2 millimeter envelope. This configuration lends itself well to scaling of multi-PLD arrays, where the PLD chips can be placed in very close proximity to each other with high alignment precision. Such an arrangement enables scanning systems with fewer moving mechanical parts and lower overall production costs. Some PLD vendors, such as Laser Components, are now offering hybrid solutions which achieve sub-2 nanosecond pulse widths and tens of watts of peak optical power. With persistent and growing market demand for smarter and more capable LIDAR sensors, a reasonable cost innovation by PLD manufacturers will continue to play an important supporting role in the successful implementation of scanning LIDAR systems of increasing complexity.
Hi, my name is Dragan Grubsic. I'm with the Laser Components Detector Group, and I will be talking about high-performance silicon avalanche APDs used in LIDAR systems today. Any LIDAR system consists of the light source and light detection system. You already heard about lasers used in the system, and I am going to talk about the detection side of the system. From the detection point of view, any system using any electro-optical system using time-of-flight concept has to use detectors that are very high, or have high sensitivity, low noise, and are very fast. Silicon avalanche photodiodes are meeting all those specs by utilizing internal gain mechanism in a way that they are amplifying very weak signal coming from the targets, and in that way making detectors to be very highly sensitive to weak signals, at the same time keeping the noise low. In order to have that gain process internal, these devices are using very high fields and are inherently very fast. For example, typical silicon avalanche photodiode made by Laser Components has a response time of less than 500 picoseconds, which is sufficient to meet any present and future pulse demands on the lasers in the system. Packaging aspect of the silicon avalanche photodiodes is very important from the system point of view, particularly in a complex systems like LIDAR. In some instances, manufacturers prefer to buy just the chips, but advances in surface mount packaging, like ones that you see, are allowing the very small form factor needed for this complex system, and are incorporating silicon avalanche photodiode chips into the frames or printed circuit boards, platforms, encapsulated by the optical resin, and in such a way protecting the device, as well as allowing manufacturer to use automatic equipment in order to place those components in their systems. What you see here also is application of the band pass filter, which is eliminating interferences from from surrounding light and increasing detector performance. The future trends seen with the laser sources as well as the silicon avalanche photodiodes are moving from the single components into arrays, either linear or 2D configurations, and such future components will significantly improve systems in terms of reliability by removing most of moving parts, as well as lowering the cost, because overall system size will be allowed to shrink significantly. Hi, we are happy we had an opportunity to share with you information about our lasers and avalanche silicon photodiodes produced by Laser Components. If you need any more information or help with those products, please visit our website at lasercomponents.com.